Electrolysis, Electroplating for Cambridge IGCSE Chemistry. To explain electroplating, you need to understand the role of inert electrodes and active copper electrodes in electrolysis. To get the best from this class, remember you can control the pace. Take notes, complete the tasks, including the exam-style practice problem at the end. Starting with the electrolysis of aqueous copper sulfate using inert graphite electrodes. So the setup is with an external circuit, the cathode and the anode. The electrolyte is copper sulfate solution, and the material of the cathode and the anode is inert graphite. Stop the class and list the 4 ions present in aqueous copper sulfate. Come back to check against my list. Okay, so 2 negative ions, sulfate from the salt and hydroxide from water. 2 positive ions, copper from the salt and hydrogen ions from water. What is the product at the cathode? So what is the product at the cathode? Can you identify the product and write an ionic half equation to explain its production? Stop, restart when you've done it. Okay, so the less reactive element ion is reduced, so you have to look at copper and hydrogen and decide which is less reactive. Well, copper is less reactive than hydrogen. So copper is produced at the cathode in preference to hydrogen. The equation, copper 2+ gains 2 electrons, it is reduced to form copper atoms. Copper metal is the product. We'll see a coating of copper form on the carbon cathode. Can you repeat the process for the chemistry of the inert anode? What is the product? Can you write an ionic half equation? Okay, I'm about to reveal. So hydroxide ions are oxidized unless a halide is present. Well, the sulfate ion is not a halide, so the oxidation will involve hydroxide ions. Here is the equation. 4 hydroxides, each losing 1 electron to form to form water and oxygen. Oxygen is the product. You will see bubbles of oxygen at the anode. These 2 observations, coating of the cathode with copper and bubbles of oxygen at the anode, are expected to be recalled. So let's look at the electrode reaction half equations, the ionic half equations at each electrode. At the cathode, we saw that metallic copper is formed. Copper 2+ plus 2 electrons goes to form copper. Is that oxidation or reduction? Speak out an answer. Indeed, it is reduction, the gain of electrons by copper 2+. So copper 2+ ions are reduced to form copper atoms. Gaseous oxygen is formed at the anode. Can you write out that half equation? It needs a bit more practice than this one. So write out that half equation. Stop, restart. Okay, so here's that half equation. This, of course, is oxidation. Why? Explain to yourself why that is oxidation. It's the loss of electrons. Now, you may see in textbooks, indeed your teacher may have been writing these oxidations in a slightly different way. Rather than -4 electrons on the left-hand side, the electrons may appear as positive 4 electrons on the right-hand side. These two equations are equivalent. This one with electrons appearing on the right-hand side is chemically more accurate. The reason I have given you minus 4 electrons in the equations on electrolysis so far is to emphasize that oxidation is loss of electrons. However, 4 hydroxides forming oxygen and 2 waters and 4 electrons is another way of expressing that loss of electrons. Now we need to see the meaning and significance of using active copper electrodes in the electrolysis of copper sulfate. So let's now consider the idea of active electrodes. In this case, an active copper electrode. So we're going to change the anode from being an inert graphite electrode into an active copper anode. We'll keep the cathode as graphite. It could be copper, it could be other substances, as we will see. The essential of active electrodes is that the anode is now metallic, in this case copper. So at our active electrode, the copper metal is oxidized. So the oxidation that occurs at the anode is not the oxidation of the hydroxide ion, but the oxidation of the copper metal that makes up the material of the electrode. So copper loses 2 electrons to form copper 2+. Those copper 2+ ions dissociate into solution to form free aqueous ions. The copper anode will lose mass. Copper atoms, metallic copper atoms, are turning into aqueous copper ions. There's a loss of mass from the anode. Those copper 2+ ions will be attracted, opposite charges attract, to the cathode and will be reduced in the normal way. Copper 2+ plus 2 electrons gives us copper. So copper is deposited on the cathode. So let's just run through the electrode half equations to be absolutely clear. Just as with all the electrolysis processes we've seen so far involving copper electrolytes, the copper metal is formed at the cathode by reduction. Copper 2+ plus 2 electrons goes to copper. Gain of electrons is reduction. But at the anode, copper metal, the substance of the electrode itself, dissolves at the anode. Copper loses 2 electrons to form copper 2+ ions. Those 2+ ions are released into solution. So the oxidation with active electrodes is not of an ion of the electrolyte, but the oxidation of the atoms in the electrode itself. So in this example, copper metal is oxidized to copper 2+ ions. Or we could rewrite that: copper turns to copper 2+, and we can place positive 2 electrons on the right hand side. Both of these equations represent copper losing 2 electrons. And now electroplating. Usually a less expensive metal is coated with a thin layer of a more expensive metal to improve appearance and resistance to corrosion. A typical example, silver plating of nickel alloy objects. So the setup is as in this diagram. The anode is an active silver electrode. The cathode is the metal object to be silver plated or electroplated. The solution is a silver salt solution, so the electrolyte contains silver ions. At the anode, silver metal is oxidized, so silver loses an electron to make or release aqueous silver ions. Of course, this means that the mass of the silver anode decreases. The silver anode is said to dissolve. The silver ion is attracted to the cathode and is reduced to form silver metal. So silver forms on the surface of the metal cathode, the metal object to be plated. Notice, for every silver ion that is added to the solution, a silver ion is lost from the solution onto the surface of the metal cathode. So the concentration of silver ions remains constant as ions are released from the active silver anode and silver metal is deposited on the surface of the metal cathode. So let's look at the electrode half equations. Silver metal is formed on the surface of the cathode. Can you write the relevant ionic half equation for the reaction at the cathode? Stop, write it, restart. Silver ions gain electrons to form silver metal. That, of course, is reduction, gain of electrons. Silver metal dissolves at the anode. Can you write the relevant half equation? Stop, restart. Okay, so silver loses an electron to form silver plus ions. That, of course, is oxidation. We may write that equation as with a positive number of electrons on the right-hand side. Both equations or half equations express the loss of electrons by silver. Here's the problem. A steel object can be electroplated with copper in the apparatus as set out below. Here we have the copper anode, the steel object as the cathode, the electrolyte aqueous copper 2 sulfate. Complete the ionic half equation to describe the chemical process taking place on the surface of the steel object. So complete this half equation. Explain why this half equation is classified as a reduction. Explain why the concentration of the electrolyte in terms of copper ions remains constant during electroplating. To electroplate with nickel, what two changes to the apparatus setup is required? Answer these questions, stop the lesson, restart to check my answers. Okay, so what's happening at the surface of the steel object is that copper is being deposited as copper 2 plus ions are reduced to copper metal. This, of course, is a reduction because copper ions gain electrons. The concentration of copper ions in solution in the electrolyte remains constant because for each copper ion deposited at the cathode, so we're depositing copper ions as copper metal at the cathode, an aqueous copper ion is formed at the anode. At the anode, copper is oxidized to form copper 2 plus. What two changes to the apparatus setup would be needed to nickel coat the steel object? Well, we need to replace the anode with a nickel anode and replace the electrolyte with a nickel salt, such as aqueous nickel sulfate. Well done for finishing the class. If you need more practice, use textbook questions and then past paper questions. Keep to that order. If you want more classes, look at the course list and links in the video description. If you found the class helpful, please recommend it to a friend. Subscribe for new classes, online assessment opportunities and exam tips. Please like, and comments are always appreciated. Thank you for watching.